Good afternoon. Today's lecture is about catalytic converter. Actually, the catalytic converter is a device which can be used to reduce the toxicity of emission from internal combustion engines. Probably you can see from the textbooks it was invented in the year 1950 by Eugene Hodry. But in the 1950s, there is a problem about the tetraethyl lead present in the gasoline, so which is nothing but a highly poison chemical. When the converter is working, it forms a coating on the catalyst surface, which is effectively disabling the conversion. However, in 1973, a new catalytic converter was developed by John Mooney and Carl Keith at the Engelhard Corporation, creating the first production of catalytic converter. Actually, as I mentioned earlier, the catalytic converter can be used in the motor vehicles exhaust systems. Not only there, it can be used in a generator and forklifts, and also in mining equipments, trucks, buses, trains, and also in other engine equipped machines. The catalytic converter provides environment for chemical reaction where toxic recomposition by byproducts are converted into less toxic substances. As you can see in the picture, the catalytic converter used to be fixed between the exhaust system as well as in the storage fuel tank. But how are you going to make these catalytic converter? What are the uses? As I mentioned, can be used in internal combustion engines. But to make or construct the converter, there are two different types of base material is required. One is nothing but ceramic core, and other one is a metal core. Usually in the ceramic core, the people might think about the honeycomb structure, which can be used in the modern catalytic converters, which is nothing but the stainless steel. It's a stainless steel foil, and which has a honeycomb structure. Why do we need a honeycomb structure? Is a interesting question, because honeycomb surface increases the amount of or maybe the surface area has been increased, which is available to support the catalyst, and therefore they used to call as a catalyst support. There is another material which is required, which is to make sure this converter is working very smoothly, which is nothing but the wascoat. It can be used for more efficient mixing with which is made up of a mixture of silica and aluminum. So wascoat, when they add it to the core, it forms a rough or maybe a irregular surface, as you can see, which has a greater surface area than the flat core surfaces. And however, also it can give a converter core a larger surface area, therefore more places for active precious metal sites. And as you can see, the catalyst is added to the wascoat in a suspension before being applied to the core. There are three different elements can be used in the catalytic converter to act as a catalyst. There are nothing but platinum, palladium, and rhodium. As you know, all these three elements might have their own property. Either it can be used as a catalytic reduction converter, or maybe for oxidation catalyst. As we all know that platinum and rhodium can be used as a reduction catalyst. Reduction is nothing but the taking up the electron, and platinum and palladium are used as a oxidation catalyst, which is nothing but removal of electron. Not only platinum, palladium, and rhodium, cerium, iron, manganese, and nickel are also be used. So what are the types of catalytic converters? Very interesting, because as you can see in the picture, they may have two-way and three-way types of catalytic converters. We will see one by one what are the mechanism, reaction or action mechanism of those two catalytic converters. In two-way catalytic converter, only two reactions are possible. The first one is nothing but oxidation of carbon monoxide to carbon dioxide. This oxygen may take up from the atmosphere, and unburned hydrocarbons which are available in the fuel, so it can be oxidized into carbon dioxide and water. But the problem, disadvantage with the two-way catalytic converter is it cannot be used for nitrogen containing gases such as NOx. So they developed a three-way catalytic converter. The first reaction it used to be happen there is a reduction of nitrogen oxide, and NOx will be converted into nitrogen, and the further two reactions are already happened in two-way catalytic converter: oxidation of carbon monoxide to carbon dioxide, and unburned hydrocarbons which are available in the fuel can be converted into carbon dioxide and water. However, there must be another disadvantage in the three-way catalytic converter also. It's nothing but the formation of very bad smell hydrogen sulfide and ammonia. So what they used to do in the catalytic converter, since they are facing these kind of disadvantages, they want to have how it can be damaged, how the catalytic converter can be damaged, because it's nothing but a catalyst poisoning, and also it occurs in the catalytic converter when it is exposed to exhaust the containing substances which are coated on the working surface and encapsulating the catalyst so that it cannot contact and treat the exhaust. The most notable contamination or contaminant in this catalytic converter is the lead. As you can know, lead is one of the carcinogenic element which is highly poisonous, and in any conditions, either in higher altitude or in lower altitude, which causes abnormal high levels of unburned hydrocarbons, because the raw material or a partially burned fuel can reach the converter, which will be significantly elevate its temperature, so that it will bring a risk as a melting point of the substrate, and resultant catalytic deactivation is also possible when the severe exhaust is restricted. And what are the negative aspects of catalytic converter? I would like to say that some early converters designs create a great deal of restriction to the flow of exhaust, which negatively affect the vehicle performance, drivability, and also the fuel economy. And the second point, which the negative aspect of the catalytic converter is, the catalytic are known a lot of cases to have an excessively long warm-up time period. Say for example, it requires minimum 30 minutes for the warm-up, so the fuel will also be wasted during those 30 minutes time. And another important aspect of the catalytic converter is how these catalytic converter affect the environment. As we already know, there must be a reduce in fuel economy of cars, resulting in a greater use of fossil fuels. So the depletion of fossil fuel will also be happen, and the catalytic converter are effective at removing hydrocarbons and other harmful emissions. Most of the exhaust gas leaving the engine through the catalytic converter is a carbon dioxide, which is responsible for the greenhouse effect, as we all know, the depletion of ozone layer. The catalytic converter production requires either a platinum or a palladium, which are all the precious metals, and so as a consequence, the cost effective will also be affected, and more importantly, it removes up to 90% of the harmful gases. With this, I would like to conclude this lecture, and we will discuss about the metal and alloys in the next lecture. Thank you.